Good morning. Welcome to Mission Control Houston. This is the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston, where a team of specialists is working, monitoring the systems on the station, and getting ready for the first planning conference of the day with the Expedition 55 crew members, who slept late today because they're going to be up late tonight. And that's because there is another ship in the vicinity. The Soyuz space capsule that launched from Kazakhstan Wednesday with 3 new crew members on board is closing in on a docking to the space station in just a few hours. And Commander Anton Shkaplerov and flight engineers Scott Tingle and Norishige Kanai will be shaking hands with 3 new crewmates just before their lunch break late this afternoon.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Gary Jordan. Right now we have a few more crew members on their way to the International Space Station. Drew Feustel and Ricky Arnold of NASA, as well as Oleg Artemyev of Roscosmos, lifted off from the Baikonur Cosmodrome on March 21st. They're now on a 2-day journey to the space station to join their fellow crew members, Scott Tingle of NASA, Anton Shkaplerov of Roscosmos, and Norishige Kanai of the Japan Aerospace Exploration Agency, JAXA. They're set to dock Friday, March 23rd, so tune into NASA TV or our website to see the schedule and watch their arrival live. The 2 NASA residents will have to get used to their space legs pretty quickly, because next week they're heading right back out the door to go for a spacewalk. After less than a week on board the station, veteran astronauts Drew Feustel and Ricky Arnold are set to don their spacesuits for 6.5 hours of installing new equipment and cameras outside on Thursday, March 29th. One of the primary tasks is installing additional wireless communications equipment for an experiment called EcoStress that will measure the temperature of plants on Earth to better understand how much water they need and how they respond to stress. We'll cover the whole excursion live, so once again head to nasa.gov/NTV for the latest on how you can watch the spacewalk while it's happening. Suda on Twitter wants to know if astronauts' movement on the space station affects the station's orbit. Well, not the orbit per se. It's pretty stable at 250 miles above the Earth. But think of Newton's third law. Every action has an equal and opposite reaction. Every time an astronaut pushes off a handrail or wall of a module, that astronaut is applying a force to the station. The station is huge, so the force does very little to the whole structure. What little effect it does have is automatically corrected for by the attitude control system on the International Space Station. Mark Vande Hei did a demonstration while he was on board the station recently to demonstrate Newton's third law, using a basketball and his fellow crewmate Joe Acaba to show the difference between applying force to an object of much smaller mass and an object of equal mass, respectively. Keep sending in questions using the hashtag #SpaceToGround. We'll see you next week.
You can follow along and see Oleg Artemyev, Drew Feustel, and Ricky Arnold pull up in the driveway and honk in just a few hours. Live coverage of Soyuz arrival at the International Space Station begins at 2 Central Time this afternoon on NASA TV and NASA.gov. Docking to the Poisk module should happen at 2:41 p.m. And come back at 4 o'clock Houston time this afternoon, when we'll be back with live coverage of the opening of the hatches, the crew members' greetings, and the welcoming ceremony. As Gary mentioned, Feustel and Arnold will turn right around to do a spacewalk next Thursday morning. NASA TV will provide a briefing to preview the spacewalk coming up on Tuesday, March 27th at 1 p.m. Central Time. That spacewalk next week will be the 7th of Drew Feustel's career. 3 of those were around the International Space Station during shuttle mission STS-134, and the first 3 took place amid high drama on an icon of astronomy.
How would you like to be the guy on the last servicing mission of Hubble to do the first thing on the mission, which is the most important thing, and then break the bowl? Well, I grew up in Detroit. Detroit's the Motor City. My father and uncle were both engineers for Ford Motor Company. I was always exposed to, mechanics and mechanical things, and then while I was attending community college, I landed a job, classic automobile restoration shop, and particularly work on old 1950s Jaguars. And that was where I guess you could say, worked professionally as an automobile mechanic and restoration specialist. And being a mechanic has been very beneficial to me, I think, as an astronaut. My first mission was repair of the Hubble Space Telescope, and I think that my skills and my aptitude with tools had a lot to do with the assignment to that mission, because the first EVA that we did was to replace the Wide Field 2 camera. My first flight to space, my first EVA ever, my first task in space was to go out with a wrench and release the bolt on wide field camera 2. And I was doing my job, got in my suit that day, went outside, got on the arm, got my tool out, went up to the telescope, and tried to release the bolt, and the bolt was stuck.
Think it's just slipping. Yep.
So eventually they said, okay, take the torque limiters off and just, release the bolt. There's really no way to control whether you're going to break it or not. And so that's what we did. I just put as much force into it as I could.
Okay, here we go. I think I got it. It turned. It definitely turned. Yep, it turned.
And luckily, it came loose instead of, breaking in the telescope. It actually came loose and we were able to retrieve it. I'm proud to be a mechanic. I'm proud to work with my hands. That skill set has been very valuable to me, and we know that from astronauts who have been to the space station before us that much of the work that we do in space is about keeping the systems operating, keeping the experiments operating, working outside with external repairs on EVA, spacewalks, and all of those things that we do involve tools and working with tools and making repairs to equipments. I've just really been lucky in my career that I had that skill set that I brought with me into the office. I'm Drew Feustel, and I'm an astronaut. Follow your dreams.
We'll spend a few moments with Ricky Arnold coming up shortly. Arnold and Feustel are joining a crew that's planning to spend a larger portion of its time on science, and that will accelerate progress on the dozens and dozens of experiments underway on the station during Expedition 55. That may include another run on the Plant Gravity Perception Investigation, which is germinating seeds in microgravity to study a plant's ability to detect gravity and adapt to grow in that environment, which is going to be necessary for future missions to deep space on which crews will need to grow some of their own food.
Think about the fact that the shape of every plant you've ever seen is the result of gravity sensing. Every plant has gravity sensing cells, and those cells contain dense bodies. They're packed with starch, and when that organ is displaced away from its starting position, those dense starch-filled packets, they fall to the lower wall of the cell. What we don't know is much about what happens after that. And so our experiment is aimed at what's the least amount of gravity that a plant can detect and cause that kind of sedimentation. And the way we're getting at that is to add fractional gravity to plants as they grow and ask the plant, how about that? Can you feel that much? How about here's a little bit more? We'll turn it up just a little more. Can you feel that? We're growing 120 of these at all different gravity levels on the station. So we have planned a whole series of experiments at fractional gravity levels while we're visualizing the plants as they grow. So we have a cell culture chamber that has 2 rotors, centrifuge rotors, and these sort of stack, they align along the radius of the rotor at different distances. And the amount of gravity experienced by the plant varies depending on how far it is along that rotor arm. Our lowest treatment, I think, is down to about 6 1,000ths of a G, all the way up to 1 G to get a good control for Earth response. Plant shape is critical in breeding programs to determine optimal growth for crop productivity in roots and in shoots. So lots of potential applications, both off the Earth and on the Earth.
The International Space Station is designed to enable future exploration of space through experiments like plant gravity perception to feed future explorers, as well as by learning how to protect those explorers during their lengthy missions. NASA's Human Research Program is working on research and technology development on systems that will enable people to live and work in space effectively over long periods of time. One of the most challenging aspects of sending human beings out beyond low Earth orbit is dealing with space radiation.
For the journey to Mars, the Human Research Program works to project, assess, and solve the problems that astronauts have in space. Specifically for radiation research, the Human Research Program works to predict and mitigate the health effects of space radiation on astronauts.
I think one of the most challenging parts for the journey to Mars in terms of the humans and not necessarily the technology to get there is the risk of radiation exposure and the in-flight consequences of the exposure to radiation, as well as the long-term health consequences of exposure.
There's two parts of radiation we have to protect the crew from. One is a solar particle effect, where there's a solar storm and these energetic particles stream out. Fortunately, we know how to protect the crew from that. We put them into a shelter that's shielded by lots of water. And actually, they're very short duration, hours to days at most. They can come out and continue with their journey. That's the one aspect of radiation we know how to protect against. The other, which we really don't have a firm handle on, is galactic, cosmic rays. These are highly energetic particles that come from all over the galaxy towards the solar system and Earth. You can't shield against these. They're so energetic, they rip right through all metals, all plastic, all water, and all cellular material. And as they rip through these materials, little electrons and protons pull off of them, and you end up getting a cascade effect of radiation throughout the materials. And sometimes going through certain materials causes a worse radiation environment for the crew than had it gone through other materials. So we try to design the spacecraft out of materials that shield the crew from these, but also do not produce more hazardous particles as a function of being impacted with it. So a lot of people think that radiation will keep NASA from sending people to Mars, and that's not what the current situation is. We have techniques, we've discussed ways of getting there faster. We know that we add these various mitigations up, that we can have a successful Mars mission, a healthy crew, and have them live a very long and productive life after their return to Earth.
The lack of gravity in Earth orbit makes the International Space Station a one-of-a-kind spot for scientists who want to find out how natural forces function without gravity's influence. In this Speedy Time segment, astronaut Jack Fisher uses a few simple tools to demonstrate what happens to water in space when there is no pull of gravity.
Today, we're going to look at one of the coolest parts of having experiments on the space station. It's because we can separate one of the most dominant forces, gravity, on a lot of different models. A great example is water. Water is pretty much dominated by gravity on Earth, but there's other forces at work that if we understand better, we can have a better model and make greater discoveries. Things like surface tension, capillary action. I'm going to show you today by taking this wonderful bottle, repurposed from a condiment, and blowing into it. When I displace the fluid with air, it will come up the straw and cover my face.
The ability to look down on the Earth from 250 miles altitude makes the International Space Station a terrific spot for some scientific experiments, especially those which want to make scientific observations of the Earth over an extended period of time. The RapidScat wind measurement system has been doing just that for more than 3 years now.
A new angle on global wind measurements, presented by Science at NASA. Summer can bring with it a whirlwind of activity. Hurricane season causes potential havoc on land with threats of forceful winds and torrential rainfall. A helpful set of eyes mounted on the International Space Station allows scientists to observe these massive storms from a special angle, 51.6 degrees to be exact. That is the inclination of the space station's orbit around Earth. NASA's ISS Rapid Scatterometer, or ISS RapidScat, was launched and fixed to the space station in September 2014, giving it a view of the planet below that differs from any other wind measuring instrument. Brian Stiles, ISS RapidScat Science Processing Lead at NASA's Jet Propulsion Laboratory, says, because of its inclination, RapidScat observes storms in higher latitudes much more frequently than polar orbiting scatterometers. The same location can be observed several times per day, and this lets us see how storms are developing in more detail. The data that RapidScat provides is being used by NOAA to support marine weather forecasts and warnings, providing better observations of storms as they intensify and weaken. Zorana Jelinek, RapidScat project scientist at NOAA, says, RapidScat observations greatly aid in our ability to study temporal changes of wind fields. When observations are available, we have the ability to study changes within 1 hour at high latitudes. Previously, we were only able to characterize changes every 6 hours. In the tropics, RapidScat has improved the wind coverage of the space-borne scatterometer constellation from once every other day to more than once a day on average. ISS RapidScat is a radar, bouncing microwaves off the ocean surface and measuring the echo. Rough waters, those disturbed more by wind, return a stronger signal than smooth waters. From that information, scientists can derive wind speed as well as its direction based on the orientation of the waves. RapidScat excels at measuring winds at the ocean's surface, adds Stiles. Measurements of surface winds are important for many reasons. For one thing, surface winds define how the ocean and the atmosphere interact where they meet, which influences weather in the short and long time scales. Moreover, surface winds are what boats experience at sea, and people and buildings actually experience when a storm makes landfall. RapidScat provides remotely sensed ocean surface wind speeds and directions. With such a huge void of radar and surface observations over the oceans, remotely sensed ocean surface winds play an instrumental role in marine decision-making, forecasting, and modeling. Stiles says this is useful information for both weather forecasting and climate studies. Since it was launched, ISS RapidScat has seen dozens of storms, big and small. Maps of surface winds have given Earth scientists a unique view of the inner workings of these storms. The orbit of the space station covers the majority of the oceans from southern Canada all the way to the southern tip of South America every 48 hours. This means few storms escape RapidScat's relentless microwave scanning. These advantages are enticing weather forecasters and climatologists to make increasing use of the high-resolution wind data that ISS RapidScat offers. The information from these data are being utilized by marine forecasters at NOAA to help forecast, warn, and analyze wind and wave conditions over the ocean environment, from hurricanes and windstorms to fair weather conditions. Improved knowledge of impending wind and wave conditions impacts everything from large cargo ship routing to recreational boating to families vacationing along the coasts. As summer unfolds, ISS RapidScat will have a lot to do. For more from the International Space Station, go to www.nasa.gov/station. Stay tuned for updates from science.nasa.gov.
A few minutes ago, we heard astronaut Drew Feustel talk about his background as a car mechanic and how he's put his expertise to work as an astronaut. His crewmate Ricky Arnold will tap into his own experience as a classroom teacher to support the year of education on station, when crew members take part in activities designed to help teachers and students get the most out of learning about science, technology, engineering, and math. Arnold's path to becoming a teacher was influenced by an educator he never met after he had already finished college.
I enjoyed teaching different subjects because it was an opportunity to learn about different things. I always thought that was one of the greatest deals about teaching, is you get to learn alongside students. Yeah, it wasn't a single point in time where I really decided to become a teacher. I was right out of university. I was working at the Environmental Protection Agency. I was actually out at lunch and was on my way back in, and on the television was the Challenger accident, and we lost Challenger that day. But I guess having a teacher on board that mission was very personal. Everyone knows a teacher. thought it sent a pretty powerful message as to what NASA thought of the teaching profession. They recognized then that there's some really talented people working in our nation's public schools. And that kind of planted a seed about, that's a really kind of a unique profession that I hadn't really considered. And kind of a confluence of events kind of shaped my decision to go into teaching. And it was a really rich and rewarding career. Well, there's a lot of things I'm looking forward to going to the International Space Station. One, I got to help build it, and now I get to go live and work there. You may know Joe Acaba is currently on the International Space Station, and he and his crewmates have been doing some demonstrations from orbit, demonstrating STEM subjects from the International Space Station, which is a fantastic platform for education. Going back to the Challenger mission, I've always kind of wondered what was Krista going to do while she was up on orbit. And that mission, unfortunately, was never completed. But we're going to have the opportunity with our crewmates to kind of bring that mission full circle. And we're going to actually conduct some of Krista's lost lessons that never had the opportunity to do because of the Challenger tragedy. To me, it's for our nation. It's really important that wasn't lost. Free of gravity, the demonstrations in physics, the principles surrounding gravity are really easy to demonstrate in fun ways. So I'm hoping that we can package up some nice stuff that teachers can use as a resource long after we're home and long after the mission's over, that the education and the tie into the space station will continue. Hi, my name is Ricky Arnold. I'm a classroom teacher and a NASA astronaut. And I'm getting ready to go to the International Space Station again to fly as part of the crew of Expedition 55 and 56.
Ricky Arnold and Drew Feustel have each been to the International Space Station once before, but this will be the first time that either of them has lived there. They've had the benefit of years of training to get ready for that. Short of buying a seat on the next Soyuz out of town, how did the rest of us find out what it's really like up there? Well, we have NASA astronaut Reed Wiseman, who spent 165 days on the space station during Expeditions 40 and 41 in 2014.
Hey, NASA astronaut Reed Wiseman.
Hey.
Do you think you have a few minutes to answer everything about living in space?
I got all the time in the world.
Awesome. Well, where are we?
We are in the Space Vehicle Mock-Up Facility. It's a gigantic building at the Johnson Space Center in Houston, Texas. And this is where astronauts spend the bulk of their time training for spaceflight.
Is this the window where you took all of those really cool pictures of Earth?
This is the cupola. It's a series of 7 windows that look down on the Earth.
Nice. How big is the International Space Station?
They say it's about the size of a 5-bedroom house. It's kind of hard for me to conceptualize. In reality, it's just really narrow and really long.
How long did you have to train before going to the ISS?
About 5 years.
And how many total days have you spent in space?
165.
What's the record?
Peggy Whitson has the U.S. record, 665 days in space.
But Russian cosmonaut Gennady Padalka, almost 1,000.
Wow. What's a groundbreaking experiment that you completed aboard the ISS?
I survived.
I heard you age faster in space.
Maybe a little bit.
Is there a maximum height or age that you have to be to become an astronaut?
We used to have restrictions on that, but now it's pretty much come one, come all.
Is there Wi-Fi?
There is, but it's not as good as it is on Earth.
How do you get in contact with people on the ground?
We have space-to-ground communication systems. It's basically a radio or a walkie-talkie, and we just call on this and say hi to Houston.
Is there a delay?
Almost none.
How did you get to the station?
A rocket.
How long did it take for you to get from Earth to the space station?
It takes about 6 hours.
And how long did it take for you to get back?
Oh, that's a crazy ride. It's about 3 hours long.
Any jet lag?
Horrible jet lag.
How often do you get to talk to your family?
Get to talk to them once a week.
Ever prank call anyone?
Of course you prank call people.
Ever get homesick?
Yeah, you get homesick a little bit.
So are the beds comfy?
There are no beds.
I heard you have to be strapped to a wall.
You do?
Are you claustrophobic?
A little bit.
What else can you do in your room besides sleep?
You can read, watch TV, do some work, whatever you want.
Do you have a bedtime?
Everybody has a bedtime.
Do you have alarm clocks?
I use my watch.
How many crew members do you have?
It was me and 5 others.
Were there any language barriers?
Da Kanyeshna. Of course there were language barriers.
Ever get sick of your roommates?
No, you never get sick of your roommates.
What did you do in your free time?
Oh, you look out the window.
What's a typical breakfast aboard the space station?
It was very much like a breakfast on Earth, so I liked eggs, occasional oatmeal, maybe even a waffle.
Was the food any good?
I actually thought the food was pretty good.
What's your favorite meal on the station?
I love chocolate pudding cake.
How do you cook your food?
You can either inject it with hot water or put it in a food warmer.
What's the first thing that you ate when you got back to Earth?
I really wanted a pizza, but I saw a salad and went for it.
So did you have to work out?
You work out twice a day for about 2.5 hours, 2.5 hours.
And what kinds of exercises?
Primarily, you're either lifting weights or running on the treadmill. Our treadmill is attached to the wall, and so when you're on it, you're running straight down towards Earth. Very weird feeling.
So how do you stay on the treadmill without floating away?
Bungee cords.
So do you burn the same amount of calories as you do on Earth?
I think you burn a little bit more because your brain is always active.
I heard that in microgravity, sweat sticks to you.
It does. If you have hair, it kind of builds up in your hair and you get this big sweat bubble on your head.
How do you shower?
We have soap impregnated towels.
How do you pee in space?
Ooh. We have a funnel.
Where does your pee go after you flush?
A little bit of processing and then right back into the drinking water.
How do you pee in a spacesuit?
We have a diaper.
How much water do you have to drink each day?
You drink just about the same that you would on Earth.
Do you ever run out of anything?
Free time.
How do you get more supplies?
We have cargo ships. We have great companies like SpaceX, Orbital. We have Russian resupply vehicles and also Japanese HTV spacecraft.
What'd you miss most on Earth?
Oh, my wife and kids.
What personal items did you take with you?
Photos of my wife and kids.
Did you bring any space souvenirs home?
You always have to bring souvenirs home for your kids.
So I have to ask, what's your favorite planet?
Oh, it used to be Saturn until I saw Earth from space.
And if you were to travel anywhere in the solar system, where would you go?
I work at NASA. We all want to go to Mars.
Does the space station ever get too hot or too cold?
Oh, we keep it a balmy 72 all year round.
Nice. How about the temperature of space?
Plus 200 to minus 200
What about the temperature inside the spacesuit?
It's actually pretty warm, pretty nice, pretty comfortable because there's many layers of thermal protection.
How much does the spacesuit weigh?
Oh, it's really heavy. I think it's about 300 pounds.
How do you do your laundry?
We throw it out.
Do you have to clean the spacesuits?
Of course you got to clean the spacesuits, especially after a spacewalk.
How long does it take for you to put on a spacesuit?
About 45 minutes.
Can you put it on by yourself?
If you're in a pinch, you can put it on by yourself.
How long does a spacewalk normally take?
We train for about 6.5 hours.
And what's the max amount of time a spacewalk can last?
The maximum is about 9 hours. I think 8 hours and 54 minutes is our record.
How's the view?
Awesome.
What's the hardest thing about a spacewalk?
Just knowing that you're outside, and if you mess anything up, you've destroyed a $100 billion spacecraft.
And what's the most rewarding?
Coming back.
Sounds awesome. Well, I'm sure there are a lot more questions, but I know you're busy, so we'll save those for another time.
Sounds good.
Awesome. Thanks. Have a good one.
See ya.
If you'd like to get another look at any of the stories we featured today, check us out on YouTube and on Facebook. There are the addresses in the handy blue box. While you're there, take a look at all the other great stuff that you'll find about NASA and America's human spaceflight program. If you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. It features folks from here at NASA talking about their work, their personal experiences on the job. We post new episodes on Fridays. Today, March 23rd, my colleague Gary Jordan talks with Tina Holden about her research on the International Space Station, exploring the challenges faced by astronauts interacting with their computers in the microgravity environment. Go to www.nasa.gov/Johnson/HWHAP, as in Houston We Have a Podcast. You'll find all the episodes there. You can also listen on SoundCloud and on iTunes. This is Mission Control, Houston.